Hello and welcome to a new video. This is for Precalculus using the Math UC curriculum, and we're on lesson 26. I'm about to run out of weeks of the homeschool co-op I'm a part of before I get actually to the end of the book, but my plan is to continue going through the lessons until we get all the way through 30. So if you are following along and not a part of the co-op or part of the co-op, you can, just continue on all the way through and have like that sense of, closure and finality. Lesson 26, we switch gears quite a bit. We've been graphing trig functions, and now we're going to talk about arithmetic sequences and series. So we're going to end up with some vocabulary here and some new notation, or probably new notation. I guess it actually depends on if you've seen this before. And I'll just point out, I pronounced this arithmetic, that it is also the same as the word arithmetic, but I have never heard it called an arithmetic sequence. I've only ever heard it called an arithmetic sequence, but I mean, it probably does not matter in the long run how you pronounce it. So let's take a look. A sequence is basically a group of numbers where there's a pattern involved. So let's see, a group of numbers that have a pattern. So that, it could be that we just have like a small group that we've listed and we just intend for it to be that small group, like 1, 4, 9, 16. This could be a sequence because there's a pattern here. These are all perfect squares. Or it could be that we actually want to say that keeps going, right? And so to do that, we would put a ... after it, and that says, okay, the sequence is 1, 4, 9, 16, and all of the numbers after this that actually go along with it as well. The other thing we like to do in math is, for notation at least, is when we're talking about a group of numbers, we will put squiggly brackets around it to say that it's a group. Another word for that, by the way, is set. This is a set of numbers. So you're going to see some squiggly brackets quite a bit in this lesson and probably the next one, and that's why it's supposed to mean something special, that this is a specific group of numbers that we're talking about. The word series, I've always thought, is a little weird in this whole situation. When we're talking about an arithmetic series or a series in general, we're actually talking about the sum of the group of numbers we have. So the sum of a group of numbers. And again, this group of numbers has a pattern. Because it has a pattern and we're adding these numbers together, there's typically a shortcut we could use. And we wouldn't need the shortcut if we were only adding like 4 numbers together. But if we're going to add 100 numbers together, then a shortcut or a formula might be super helpful. So as we look at sequences and series, there's 2 specific types that we typically look at initially. And we're doing the first one this lesson, and I think the other one is the next lesson, if I remember right. So an arithmetic sequence or arithmetic sequence is a sequence where each term has a common difference. And can we just take a moment here to appreciate some mathematician or group of mathematicians' ability to name something an oxymoron, because it's common difference, and things in common are different, right? But this actually ends up making sense because it's talking about that. This is a sequence where however much is between each set of terms is the same each time. And so if we subtract any 2 terms that are next to each other, we'd get the same thing. I feel like that's a really difficult way to basically say that a arithmetic sequence is a sequence where you are adding the same number or subtracting the same number, because we could add a negative number. This would be an example, 20, 22, 24, 26, where we're adding 2 each time, so it's an arithmetic sequence. So this common difference that I have here, the common difference is how far or how much you would have to add or subtract. Well, we'll just say add. How much you add to each term to get the next term. And this is a vocabulary word or whatever you want to call it that's specific to arithmetic sequences. Other kind of sequences won't have a common difference, because if it has a common difference, it is an arithmetic sequence. So those go together. There's going to be some notation used with sequences where we use subscripts. So if this was our sequence, 20, 22, 24, 26, 20 would be the first term. And so we use A, and I don't actually know for sure why we use A. It's not because it's arithmetic, because we also use A whenever it's a different kind of sequence that doesn't start with A. But since this is the first term, we could say that it is A with a 1 as a subscript. So that's the opposite of like a superscript, which is an exponent. It's down and lower and also smaller. So A1 is 20. The second term, which is 22, is A2. The third term, 24, is A3. The fourth term, A4. And we could go all the way and talk about the nth term. Now, it's kind of a weird phrase to think about or to say. The nth term of a sequence, we would be talking about, hey, what's a formula that would let me actually come up with whatever term that I wanted to, whether it's the 7th term or the 100th term. We could say, hey, here's our formula. That lets us get that. I'm trying to think if there are any other things to notate. Got A1, AN. So the common difference, we use the letter D. N, in general, is number of terms. So if they give us an N, like if they label something N, that's what they're talking about as number of terms. Or if we're saying A of N, the N there talking about what term we're on. There, we're going to see the Greek letter sigma right here, which is a symbol for finding the sum of something. So that's going to kind of go along with the series. The other one I'm seeing, because I'm looking at the workbook to make sure I get everything. They use the letter S, and S usually means that you're finding the sum. So if I asked you like S of 5, which was a terrible number to pick because it also looks like an S, this would be the sum of the first 5 terms of whatever my sequence would be. Well, that's not how the Math U C workbook is using it. They're saying S is just, what was it that they said S was for? Not sum. I don't actually remember what they said they were using S for in the instructor book, but oh well, we'll deal with that later. There are some formulas that we can use with arithmetic sequences and series, and that's one of the reasons that we like arithmetic sequences and series, aside from the fact that they actually come up a lot, because an arithmetic sequence, which we're adding the same thing each time, is essentially a linear relationship. And there's lots of things in life that are linear relationships, even if we don't necessarily notice them at the time. So if we're just trying to find the nth term of an arithmetic sequence, we can use this formula up here that uses the first term, uses how many terms you're trying to get to. You actually take off 1 from that, times it by the common difference, and then that gives you whatever term it is you're looking for. And that has to do with the fact that we're starting with a first term that may not have anything to do with common difference. So we're starting with a first term, and then we have to add to that, like, what would you call it? Like n minus 1. So like 1 less than the terms we're looking for. That's how many like spots we've moved over, right? So that's why it's an n minus 1. This is a weird situation where like I've pretty much only ever seen this formula written this way with the D on the right side, even though normally we put things like that in front of our parentheses and use the distributive property, like it still is saying the same thing. I guess really it's that quite a bit of the time we are going to plug in and get a number here. So it doesn't really matter that the d's at the end instead of at the beginning. For the sum of the first n terms of an arithmetic sequence, we have two formulas that we can use, and it depends on what information you're given, what you would actually want to use. And alternatively, because of the way the Math U C workbook actually writes out the sums they want you to do, your calculator also will really nicely do sums as well. So it's kind of your choice as to what you'd like to do. But if you have a TI calculator, you would be able to use the math button to go to the line that says summation notation. It's actually really straightforward. You basically make it look exactly like what the problem looks like, and it gives you the answer, because calculators are cool like that. Let's take a look at some examples. All right. On this first example, we are going to describe the sequence and find the common difference. So the way we could describe the sequence, I actually don't know what they're looking for, as I didn't look at the answer booklet for this, but I would describe this sequence as being that it starts at 5, and goes up by let's see, between 5 and 9 is 4, between 9 and 13 is 4. So it's going up by 4. Another way to write that would be to use our notation. A1 is 5, and D, which is our common difference, is 4. So hopefully that seems pretty straightforward and easy. On B here, this starts at 7, and it actually goes down by 8. And the reason to have both of these actually is to point out, okay, A1 is 7, D is -8. So you can have a negative common difference, and that means that you're actually subtracting instead of adding to get each of your next terms. So that's how we would do that. Example 2, find the first 5 terms of the arithmetic sequence. This first one, we're given the first term, so we actually already know the first term, and then the common difference. So we're just going to add 2 to the first term, and that gives us the next term. And we're just going to do that until we have 5 of them. So, and we don't need to put the ... because we were just supposed to put 5 of them. I guess you could if you wanted to, but some would argue that that's not correct for the ... On B, I put these squiggly brackets here because the workbook has squiggly brackets around it, and I do not understand why the squiggly brackets are there. Squiggly brackets are used to notate sets, but when we have an equation like this, we don't normally put that in set notation. So I found that confusing, and maybe you did too. What we want to do, since they gave us the formula A of n, is to find the first term. It's kind of like function notation, actually. To find the first term, you would do -4 times 1, because n is 1, and then add 9. So we work this out. -4 times 1 is -4, plus 9 is 5. So the first term is 5. And then we do that with 2. And you might be thinking, man, this is more effort than what we did over here. But there's a pattern, right? That's the whole point of this, actually. That this is a pattern. So the first term was 5. The next one was 1. This number in front of n actually is what tells us like what we're going down by. In this case, -4. But we can also see that by saying we have 5 and then 1. So we can just continue the pattern instead of having to write this out and plug it in for all 5 terms. It's up to you with whatever you're comfortable with. But that's the idea there as far as the notation goes of whatever term I'm looking for, I put in for both of these n's and then work it out, and that will tell me what the term is. And so example 3, let's find the 100th term for this. Now, This is not where we're going to like sit here and make a list. What we're going to do is we're going to use that formula that was on the slide earlier for the nth term is the first term plus n minus 1 times d. So for this situation, a1 is 10 and d is negative 7. Now I actually could have gone ahead and put in n as well. I'm not sure why I didn't. This is the formula to find any term you want. We want the 100th term. So let's do a with this little 100. 10 plus 100 minus 1 times negative 7. Well, that parentheses got a little carried away there. I'm going to use my handy dandy calculator, which is low on battery, so hopefully it doesn't run out on me. To do 100 minus 1 is 99. Times that by negative 7. And then add 10, and I get negative 683. One of the things I like about these sections is that students tend to think that it's pretty straightforward and easy. The most difficult part of this section would be having to memorize the formulas if that's something your teacher wants you to do. But the cool thing is, if you forget the formula, but you're allowed to use a calculator, you could sit here and pretty easily add negative 7 to 10, what ends up being 99 times, to get negative 683. So this is definitely we're learning about a shortcut to something that you absolutely could take. I don't know how long that would take you to do it the long way, and that would be fine. Let's look at example 4. This is called summation notation. This is the Greek letter sigma. And so when you see it in math, it's saying to add a whole bunch of numbers together. What numbers are we adding together? It comes from what's underneath and above. Whatever this bottom number is, which it will tell you the variable that's involved here. So k equals 1. K is also the letter we have on the right side here. But it's saying start with 1 and plug it in. And keep doing that until you get to 15. And then take all of those answers and add them together. So if we were to do this by hand, we'd have to do 2/3 times 1 minus 5. But then we'd add that to 2/3 times 2 minus 5. I say by hand. We'd still probably put it in the calculator, right? This is what it's asking us to do. 2/3 times 3 minus 5. It wants us to do that. That was one too many dots. I'll just turn it, well, I should have put another plus sign actually. So if I'm trying to model the actual way to notate this, I would need to put another plus right here. And then, okay, 2/3 times 15 minus 5. So this notation is saying, like, I'm showing you what I'm doing, but I'm skipping over that I have a whole bunch of them, and then I'm showing you, here's the last one. So this is a lot of effort to put this in. So there's a couple ways we can shorten this. One way is to realize that this is an arithmetic sequence and to use one of those two formulas that I had on the screen earlier. And actually, because of the way I wrote this, I can know the first and last term relatively easily because it would be the 2/3 times 1 minus 5 and the 2/3 times 15 minus 5. And so that first formula, the formula that was on the left, you add the first and last term together and then you times it by the number of terms divided by 2. So that's an option. It's also an option to use the other formula, which just needs the first term and the common difference. You just have to figure out what is the common difference here and what's the first term. Alternatively, our calculators will do this completely on their own. You go to math on your TI calculator. It's actually faster to scroll up and you're looking for summation, which is, can I get the calculator? Yeah, not worth it. Oh no, and now you can see the wall behind me. Mistakes were made. Mistakes were made. Hey, can you fix yourself? Oh, this is awkward. I apologize that I think I just ruined the green screen effect for you a little bit. So, here's how we do this. I wonder if Desmos does this actually. Surely it does. Yes, it does. So on Desmos, you want to go to the keyboard and the function button, and it has a little summation thing right here. The letter that we're using actually doesn't matter. So this says n equals 1, or this says n equals. You can probably change that if you want to. On your TI calculator, the easiest letter to use is X because you have that special X button. So it doesn't really matter what letter you label it as long as you are consistent, and whatever you put over here, you use the same letter. So that was 2/3, not K. It was K, but I'm not using K. -5, is that what it was? And it tells me the answer is 5. 2/3 K minus 5, 2/3 N minus 5, 1 to 15. Seems like such a weird answer. So when I press enter on summation on my calculator, it makes me pick a letter. If you notice, it has a flashing cursor that has A. If you've never noticed before, up and to the right above each key, there's a letter. And so we actually can pick to use K if we want to pretty easily. That's the parentheses button. But just whatever letter you use there, you'll need to use later on. So I just am gonna like double check this to make sure that it also says 5. It also says 5. Go figure. Like, what are the odds? So the answer to this is 5. Voila. So like I said, this is us finding the sum. There's a bunch of different ways we can do it. We can use the calculator to help us here, which is really neat. So yeah, that's awesome. Thanks so much for watching. I hope you enjoyed the video, and be sure to check in next lesson for a different kind of sequence and series. Bye.